Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone and Ustazah. My name is Rihadatul Aisy R and I am from 10E. Will present you my chemistry remedial video. So let's just go through to the number I wrong at. Okay, let's go through the number 2. Ion X2 plus has the same electron configuration as the atom krypton, and we know that krypton is 36. And to determine the X, we have to add it by 2 because the charge is 2 plus, so 36 plus 2 equals to 38. So the electron of atom X is 38. Let's look at the option. We know that we already have noble gas argon in here, already have 18 electrons, so we need 20 more. Let's look at the option A. 2 plus 10 plus 6 equals to 18, but it means this is wrong. Option B, 2 plus 10 plus 6 plus 2 equals to 20, and then this is the right answer. So the answer for number 2 is B. Let's go to the number 4. In which option do all three particles have the same electron configuration and the same number of neutrons? It's easier to find the number of neutrons than the electron configuration, so I will search by search number of neutrons. First, we have 15 nitrogen, so we know that nitrogen has 7 proton, so we minus it. 15 minus 7 equals to 8, and then for oxygen, it has 8 protons, so 16 minus 8 equals to 8. And fluorine has 9 protons, so 19 minus 9 equals to 10. But all of these three is not the same, only 2 that the same, so the option A is wrong. Let's look up into the option B. Oxygen has 8, so we minus it. 18 minus 8 is equals to 10, and then fluorine has 9, so 19 minus 9 is equals to 10 also. And neon has 10 protons, so 20 minus 10 is equals to 10, and all of the neutron is the same, so the answer is B. Let's go to which molecule has an equal number of bonding electron and lone pair electron. So for number 5, the option A is boron hydroxide, this one, and the lowest structure of this is this. Because boron have 3 electron valence and H only have 1 electron valence, and all of them is bonding together, so this is mean that we have 6 electron bonding, but without lone pairs. No lone pairs. So the option A is wrong. Let's go through the option B. We have carbon dioxide, and C have 4 electron valence and O have 6 electron valence, means that this is bonding together, and so they have 8 electron bonding. And also they have 1, 2, 3, 4 for lone pairs, means that they have 8 electron lone pair. So the right answer for this question is B. So from the question we know that methane the MR is 16, and we know that the temperature is 1600 Celsius. We have to convert it to Kelvin first, so we add 237, so we get 333 Kelvin. And we know the pressure is 103 kPa, so we have 1 atm, and then the volume is, but because this is in matter to the power of 3, we have to convert it to liter, so it's 1 Okay, first, to determine the mass, we have to find the mole first. The equation is PV equals to nRT. To find the mole, it's PV RT. We know that the pressure is and the volume is per R is 0.82. Okay, until here we got 5.53 divided by 27.306 and we got 0.2. This is the mole. So we have the other equation. Mole equals to gram per mass molecular equals to gram equals to 16 because we know the m are 16 before and the mole is 0.2. So the gram is 3. So the mass of the methane is 3.24 gram. The option D is correct. Okay, now for number 9. We know that from the question, we know that the pressure is 1 at 80 and the volume of water is 200 centimeter to the power of 3 or 200 milliliters. So we convert it to liter equals to 0.2 and oxygen we also convert it to liter. We get 6 times 10 to the power of minus 3 and the temperature is 35 Celsius, but we convert it to Kelvin plus 273 we get 308 Kelvin. Okay, to determine the concentration of oxygen we have to know the mole first. So we get the equation PV equals to nRT and equals to the pressure is 1 times volume of oxygen divided by R 0.082 times the temperature and we got 2.37 times 10 to the power of 4. And for calculating the concentration we have the equation mole equals to concentration times volume. For search the volume we got mole divided by volume. So we already got the mole and the volume that we already convert and we got 1.18 times 0 to the power of minus 3 and for this question the right answer is B. Okay, now for number 12, the question is what is the shape of sulfur dioxide molecule? I'm on number 11. So let's identify this. For AX or the double or the pair of electron, we have 1 and 2 because double bond counted as 1, so we have AX2 and E for the lone pair of the central atom or the S, so we have 1 here. So we have AXE1. This is bean shape. And in the option there is no bean shape. We only have linear, which is this is not linear. B non-linear, pyramidal and tetrahedral. So the answer is B, non-linear. 12. We have in which pair do the molecule have the same shape as each other? So in the question A, in the option A we have H2O, and this is the lowest structure, and we have carbon dioxide. So because O only have 6 valence electron, 4 valence electron, and 2 of them is bound to hydrogen, so it means it has 1 lone electron. This is AX2E. That means the shape is linear. Okay, next up to the number 12, we have option. We have in which pair do the molecule have the same shape as each other? For option A, we have H2O and carbon dioxide. For H2O, I already draw the lowest structure. It has 2 bonding or AX2 and have 1 lone pair E. That means it has band shape. And for carbon dioxide, it's only have 1 and 2 or AX2 of bonding pair, and there is no lone pair in the central atom. So this means it has linear shape, and band and linear is not the same shape, so option A is wrong. Let's go to option B. We already know that H2O is band, and we have HCl2 have 2 bonding, also AX2 and 1 lone pair E, means that it's also have band shape. So band and band shape, this is the same, and the correct answer for this number is B. Okay, for this question, we already know the enthalpy change of carbon and enthalpy change of hydrogen, because the product, this is the equation, and it makes 2 carbon dioxide, so we times the enthalpy change of carbon by 2, and we have 3 water in here, so we also do the same thing. We calculated, and because we already know that the enthalpy change is equals to minus 140, we have to calculate it also. So from this side we move to this side, B, and so we plus 140. This one also. After that, we calculated this, and we have minus 100 minus 1, 5, 6, and 0. The right answer is B. Now for number 18, because this is energy bonding, so to calculate the enthalpy change, we use reactant minus product. From the question, we know that the reactant is minus 283 plus minus 726. So we add this, and then we have to minus it, and the product is minus 874. Okay, so we got minus 134.9. This is the right answer is B. Okay, now for number 19, we have the enthalpy change of formation of combustion of ethane is equals to product minus reactant. This is the product and this is the reactant, and we already know the enthalpy change of formation is equals to minus 158, and then we search the product first, 2 carbon dioxide, which is what we want to search, and 3 of water, 3 times minus 289, and minus the reactant, we also know it from the question, minus 1560. So we calculated and get to x equals to minus 860 and x equals to minus 430. So for this question, the right answer is C. This is 410 because there is 2, so we times it by 2, and plus 440 for this. Okay, and we also have 2. We calculated this as 2.5 double bond O half. In the question, we know it's 496. Okay, and then this is the breaking bond. For the bonding, we have H2O, or we have like this H2, and for this one is 460, and because there is 2, so we times it by 2, and then we have carbon dioxide. For 2 carbon dioxide, have 2. And for it's double bond, I forgot. And for C double bond O, it's 740. And because we have 2 and times 2, we times it with 4. Okay, after we got this, we calculated and we got minus 980. And this is the option A. So for number 21, the right answer is option A. We have the equation enthalpy change equals to break minus bond. So for the breaking, this one, we have carbon dioxide is minus 283, and also we plus it with minus 726. Also, we minus with the bond, or the product is minus 874.1. And after that, we calculated this and we got minus 134.9. So this one is the right answer is C. Okay. Next, let's go to question number 29. From the question, we know the enthalpy change is minus 57, and then we know the molarity and also the volume. So because we know that, we search the mole, or the mole. Mole NaOH is equals to 0.08 and mole NaOH equals to 0.06. But we use the smallest one, or 0.06. So we have equation enthalpy change equals to molarity equals to color divided by mole. So So color is equals to enthalpy change time mole. We have minus 57 time, because we use this 0.06 is equal to 3.42. And because the question is to search the maximum final temperature, we use the Q equals to MC delta T. Because we already know the color 3.42, and also the mass here we use the total of the solution. So it's 50 times heat capacity and the delta temperature. We have to convert it, because at first this is in millimeter, we convert it to liter to this, and then we calculate it, and then we got the delta temperature is 16.28. Because the initial is 25 and the change, or the delta, is 16.28, so we have to 8. So to search the final temperature, we have to add this one and this two, and we have 41.25 or 41.3. And for this question, the right answer is A. And number 30, what is the enthalpy change of this reaction? So here we have glucose, that we already know the enthalpy change. This enthalpy change is minus 2820. And also we know this enthalpy change is equals to minus 1368. But because this is have to ethanol, I think this is ethanol, so we have to times it by 2. And we don't have to calculate the carbon dioxide, because this is just an excess. Okay, so we have enthalpy change equals to reactant minus product, and we insert the value, and minus an 8, we got minus 84 kilojoule per mole. So for number 30, the right answer is option B. 4 mixtures are added to 4 separate 50 milliliter samples of water and stir, which mixture result in a solution with the highest pH. So let's discuss it one by one. First, in option A, we have 1 gram of aluminum oxide and 1 gram of aluminum chloride. So this is the explanation. Aluminum chloride hydrolyzes in water and produces acidic solutions. This is aluminum chloride. This is AlCl3, and this is it produces acidic solution. But with aluminum oxide, this is AlO3 plus H2O. There's no significant reaction because it's with H2O. So this mixture resulting acidic solution, which is low pH. So the next is B, magnesium oxide and 1 gram of magnesium chloride. Here we have magnesium oxide with H2O, and we know it's magnesium. This is magnesium oxide. Magnesium oxide is basic oxide, so it dissolves in water and produce base solution. And magnesium chloride dissolved in water, so produce hydroxide ions and make the solution alkaline. So because this is base, it has high pH. Next, let's check it again. Option C, phosphorus oxide plus phosphoric chloride. Phosphorus oxide react with water to form phosphoric acid. Now we know it's phosphoric acid. This is phosphorus oxide and this is H2O, and we balance it and make it phosphorus acid. And phosphoric chloride hydrolyzes in water. There is no significant because it's also produce acidic. Okay, it produce acidic. So this is also acid, and nope. And the last option is silicon dioxide plus silicon chloride. Silicon dioxide does not react significantly with water. There is no significant reaction. And then silicon tetrachloride hydrolyzes in water. Like this. Produce hydrochloric acid. This is hydrochloric acid, and we also know that hydrochloric acid is acid and it's low pH, so this is not the only solution that makes high pH or base solution is only option B. So the right answer is option B. For number 34, aqueous acid P and alkali Q have the same concentration. 20 mm of P is added to conical flask. Q is slowly added to flask, and the volume of K and pH are recorded. The pH titration curve is shown. This one. And which row gives the identity of P and Q? Let's identify this first. So we know that P is very strong acid because it starts from 1. This is a very strong acid, and the option is hydrochloride, and this one is weak base, a weak acid. So let's just not count this. And then the alkali, this is the volume is 10 because they have the same concentration. So because it has the same concentration but the acid has 2 times volume of K, so we have 2 times the K with charge 2. Okay, because this means that 1 mole of concentration H plus just need this, but for 1 mole of this of alkali of Q need 2 concentration of OH minus. So let's go here. Because why not sodium hydroxide? Because the mole ratio is one by one. Concentration are equal. 2 millimeter of hydrochloric acid will require 20 millimeter of sodium hydroxide for neutralization to make it balance. But because they have the same concentration, but the graph shows the neutralization occurs at 10 millimeters, so hydrogen hydroxide cannot be Q, because F is sodium hydroxide is not balanced. That's why we need that the concentration of OH minus is 2. So we have BaOH2 in here. So the right answer of this is C. Question 30. We have this. For solution each of concentration 0.1 were tested in pH method. The results are shown. This, and we have three statements. The first statement is acid 2 has a lower pH than acid 1 because it is more soluble. Actually, this is true because this is strong acid produce H, the concentration of H plus more than acid 2. Than acid 1, I'm sorry. But that is not because this is more soluble. So statement 1 is wrong. Let's go to statement 2. Base 2 has higher concentration of hydroxide ions in solution than base 1. Yeah, it is right because sodium hydroxide is strong base and ionized fully, so the concentration of OH minus is bigger. Let's look at this is, and because base 1 is weak acid, that's why base 2 has higher concentration of hydroxide. And statement 3, acid 1 dissociate less than acid 2. That is right because acid 1 is weak acid, that's why it's not fully ionized, and acid 2 is strong acid and it's fully ionized. That's why acid 1 dissociate less than acid 2. So the right answer for this question is C, 2 and 3. And next we go to question 1B E1. State the number of occupied orbitals in an isolated atom of krypton 36. So we have the electron configuration first, and then state the type of orbital is S. From here we got 1, 2, 3, 4 orbital of S. So we got S, and because S is only have one pair, so we times it 4 times 1, so we got 1. And then we got orbital P 1, 2, and 3, and that is all full, so we got 3 in here times 3, we got 9. So this is supposed to be 9. Okay, and then we have orbital D only 1, and orbital D have 1, 2, 3, 4, 5, and all full because it's 10. Okay, that's why orbital D have 5. That is the right answer. Yes. Show relative abundance of isotope of a sample of rhodium and iridium. The question that I wrong at is calculate the relative atomic mass of iridium in the alloy. At first I answer like this, but this is wrong because we have to divide it only by 50, because iridium in this table is 15.18 plus 34.82. This one has 50. If we add it, it is 50. Because we only calculate the iridium, so we divide it by 50 and we got 192.35. Next up is what is enthalpy change of formation. So enthalpy change of formation is the heat energy absorbed or released when exactly 1 mole of a compound is formed directly from its constituent elements in their most stable standard state. Like this. We have to make it O2 because oxygen have to be O2, cannot berdiri sendiri. Yeah. So we have 2 Fa in here, and we in the product there is only 3 oxygen, so we have to 3 per 2. So later 3, this one, tak tak coret, and then we have O3. Okay, so this is the right answer for equation for Fe2O3. And then let's make equation of carbon oxide, CO. We have C plus O. O have to be 2, have to be O2. And because in the product we only need 1, so we divide it 1 per 2. So later we times it, and it's produce only 1 oxygen. So this is the right answer for this equation. So we already have the data, we have to make the reaction, and this is the equation. Cl2 plus NH3 equals to HCl plus NO2. And we make it balanced to produce this. This one. After we balance, we have here the product minus reactant. The product is 6 hydrochloride, which is, we know hydrochloride is minus 92 times 6 equals to minus 552. We minus it with the reactant is 2 weak base to ammonia, and we times it by 2. It makes minus 92. Okay, so we calculate and we got minus 460. That is all for me.
So maybe that's all for me. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.